Welcome to Aastha and Sarah Ann's lesson on ocean acidification.
What is ocean acidification? Let's start by watching a short introduction video to get a basic idea.
Our emissions of carbon dioxide are causing our climate to change. And too much CO2 in the atmosphere will also alter the very chemistry of our oceans. When carbon dioxide dissolves into seawater, it forms an acid. Just a small rise in the acidity of seawater, combined with climate change, may leave coral reefs, the most biodiverse habitats in the ocean, struggling to survive. But that's just touching the surface. By the end of the century, acidification could leave some types of plankton unable to form their shells. And plankton is at the foundation of nearly all marine ecosystems. If key species of these tiny organisms are lost, everything else that depends on them for food could also start to disappear. Carbon dioxide pollution threatens to change life in our oceans out of all recognition within the span of a single human lifetime.
Before we go more in depth, let's talk about some background information that will be useful for the rest of the lesson.
What is a carbon sink? Well, a carbon sink is a biotic or abiotic part of nature that absorbs carbon dioxide from the atmosphere. Some examples are plants, the ocean, and soil.
The term carbon neutral is quite common when talking about the carbon cycle and carbon sinks. It means that the same amount of carbon dioxide is being released into the environment as is being absorbed by the ecosystems. The amount of carbon dioxide being absorbed and released has increased since the Industrial Revolution. 42% of anthropogenic carbon dioxide emissions are absorbed by the oceans, so they're affected in major ways.
This picture shows a carbon-neutral company. This company produces 211,000 tons of carbon each year. While that may seem like a lot, there are eco-friendly business practices, such as using wind power, LED bulbs, and other green energy sources, reduce and offset these emissions. This makes the business carbon neutral and sustainable.
pH is a measure of acidity. It ranges from 1 to 14, 1 being the most acidic and 14 being the most basic. It is logarithmic, meaning that a 1-point change in pH indicates a tenfold change in hydrogen ion abundance. The ocean's pH has been gradually decreasing.
Ocean acidification is a naturally occurring system to reduce atmospheric CO2 and store it as carbonic acid in the ocean. The CO2 is absorbed by the seawater and must undergo a series of reactions to reach equilibrium. During this reaction, the ocean's pH is lowered. This process has been unhealthily accelerated due to increased carbon emissions since the Industrial Revolution. In the past 200 years alone, ocean water has become 30% more acidic, faster than any known change in ocean chemistry in the last 50 million years.
This is the equation for the creation of carbonic acid. Water and carbon dioxide react to create carbonic acid.
For the more visual people, here's a diagram that explains the chemical process. CO2 enters the ocean, reacts with H2O, and results in carbonic acid.
Deforestation is one of the main causes of ocean acidification. The large expanses of plant life are carbon sinks because they take in carbon dioxide during photosynthesis. There are also a lot of fossil fuels needed to cut down a forest. Deforestation not only creates more carbon dioxide emissions, but it destroys one of the things that helps absorb it.
Since the Industrial Revolution, fossil fuel consumption has risen exponentially. The carbon emissions when mixed with water can produce carbonic acid, and the sulfur dioxide makes sulfuric acid. When these are mixed with the water vapor in the air, they create acid rain. The precipitation adds to the acidity of the ocean and results in a positive feedback loop.
Ocean acidification is causing many parts of the ocean to become undersaturated with carbonate due to the acid-base reaction that occurs. Carbonate is used by many sea creatures to build shells and exoskeletons, including oysters and clams. In the picture to the left, you can see a healthy conch shell, but on the right is a conch shell that has been affected by ocean acidification. It is black because the acidic water has eaten away at the carbonate.
When the carbonic acid comes in contact with the carbonate in sea creature shells, it creates a new substance, bicarbonate. The carbonic acid steals the carbonate from the other organisms that need it. This damages coral and sea creatures that use carbonate to survive and protect themselves. Here is a video that gives a brief overview of the damage that is occurring at the Great Barrier Reef in Australia.
Increasing ocean acidification has been shown to significantly reduce coral reefs' ability to produce their skeletons. It also negatively affects their reproductive systems. Ocean acidification can severely impact endangered species of corals' ability to recover from disturbances. These are examples of what healthy coral skeletons should look like. With ocean acidification, coral skeletons are becoming more porous. They are not as strong and resilient as they should be.
Coral reefs provide holes, crevices, and caves for a variety of sea animals. Many animals are perfectly adapted to their reef environment, so the damage done to corals affects more than just the coral itself.
By the end of the century, coral reefs may erode faster than they can be rebuilt, thanks to anthropogenic ocean acidification. The long-term viability of these ecosystems could be compromised, as well as the habitats of over 1 million endemic species. This fragile biome may not exist for our children to see at this rate. Do we really want to destroy our planet because of industrial advances? We only have one home. This is something you should think about.
Ocean acidification will greatly affect phytoplankton populations, the base layer of the food chain. Although it is too early to accurately predict further effects, we can infer that the upper trophic levels will be affected since the primary producer is being negatively impacted.
The most realistic way for us to reduce our carbon emissions is to reduce our reliance on fossil fuels, like coal and gasoline. By conserving energy, you can reduce your carbon footprint. Ways to do this include biking instead of driving, and turning off lights when they aren't needed.
Scientists are currently working on future solutions. One technology will reduce carbon dioxide in the atmosphere without cutting carbon emissions. Other geoengineers suggest reflecting sunlight back into space. Not a direct solution to ocean acidification, but it could combat global warming and the positive feedback loop associated with it. Another idea is to create man-made phytoplankton blooms. The phytoplankton will take in the CO2 and then bring it to the deep sea when they die. However, researchers don't know the effects of this on the deep sea. It could help or it could hurt by making the deep sea more acidic.
We can also start focusing on rebuilding naturally occurring carbon sinks, such as mangrove forests.
Thank you so much for watching, and we hope you learned something new today about ocean acidification.